Thanks, Galvin. Can everybody see
Cool.
my
I
screen?
see your screen. Looking good.
Okay. Thank you so much. Thanks to IndyPy for the
I
opportunity.
don't hear you
By the
though.
way, I want that you that all. I want it.
Enter.
Okay. Hi everyone. As Calvin mentioned, my name is Adil. I'm a software engineer. I'm out of Montreal, Canada, so it's a little bit weird here the weather. We last week we had snow and -1. This week we have 20 and we're outside in shorts. So I'm sorry if I sound a little bit odd, but it go with the weather. Today I want to talk to you about a case study that we had in my old job. One of the questions that we often get from marketing people is to know how much impact each marketing initiative and each marketing effort has in a sale. This is something that might seem like a simple question, but it's puzzled us for a long time. We even paid for agency to do research, hire consultants, buy budget software, but our situation was a little bit unique since we were dealing with a mix of internal and external data, and that generates lot of friction and a lot of inconsistency in the result. So after trying all this, we've come with the idea that we already have a lot of data. Why not write an algorithm that will take advantage, of all this data and try to extract insights about the value of each marketing effort. So we needed a system that will be able to collect data, pre-process it, run some analysis, and present it in a way.
1 second, Adil, real quick. Your audio is a little bit staticky and choppy, so I don't know if there's anything you can do or if you just want to just slow down just slightly, because I know people are having a little trouble understanding because of the audio.
Okay, give me just a minute. I'm gonna check my settings and see. Okay, so let's see. Is it better now?
It's about the same, but I think if you maybe we can go with it.
Okay, give me a minute. I'm gonna see. I'm gonna try to talk slowly and to articulate any word. I'm sorry in advance. English is my third language, so I'm.
Yeah, I think if you just go a little bit slower, that'll be perfect.
Okay, so I'm gonna try to do that. Okay, so as I mentioned, once we exhausted all other possibilities, we decided to build our own custom software. This software has two components. The first one is it has to be able to process all this data, and the second one, it has to present it in a way that is accessible to non-technical people. So we started by going with Python for two main reasons. The first one is it fits the bill for everything we want, and the second one is it was like the language that our team knows the best. So we went with that. So for the first prong of the software, the challenge was, as I mentioned, to get all this data from all these sources. The data itself was accessible. The only issue is was not there is no systematic way to be able to scrub through it. Some of you, if you are familiar with some of the services, some of them offer REST APIs where we can just interrogate the REST API and get all the required data. Others didn't offer any such things, so we had to run some scripted software to get the information we needed. And for some, the data itself was residing in CSV file and spreadsheet. And like every good data system, there is some SQL out there for good measure. So we used the popular framework that everybody was doing any data and any data collection use REST, Beautiful Soup, pandas. And once our data was collected, we used pandas to run some low-level structuring, and then to run some regression to have the response to be able to get the raw data that we can feed it to our algorithm, and that we can present some of it that doesn't require any further processing. Once the processing was done, we needed a way to present the dimension, and since the team core knowledge was in web design, we decided to go with the web framework. And also, we were building most of the backend ourselves instead of going with the Django or with some heavy framework. We went with Flask because it was simple to just pick up and start with. The system itself, once it was operational, we needed a way to package it and be able to distribute it to a machine, to our team's machines. And since every member has a specific requirement, we needed all the heavy processing to be done in the machines themselves and not in a centralized location like in a server or some cloud. So we just created a version that was shippable to each member of the team and take care of customized especially to their needs. So for that we use Electron. For Electron is a Node.js framework that was developed by the team at GitHub. It was developed at the beginning as a part of their Atom IDEA, and when people start using it, when the team done with Atom IDEA, they found that they come out with a new great paradigm to software building. So they decided to ship it as a standalone project, and the Electron is based on the simple process that introduced a new subset of this application paradigm, which is that we can use web technology like HTML, CSS, JavaScript to create desktop application. The way Electron do it is it ships a version of Chromium API, which is the open source version of Chrome, with each application it builds, and it run the web language on the Chromium API, and it uses that as an interface for the user. Lately, this is something that has been mentioned since Electron was created, but lately has gained some speed. There is a lot of criticism for Electron. A lot of people say that it's not that good, and there is some issue with it. And some of this criticism is true. As I mentioned, Electron actually packaged a version of Chromium with the app. So from the beginning, the app is a large size file, and it's a little bit heavy on resources. The thing is, it's a little bit heavy on resources, either CPU or memory, or CPU or memory. I'm sorry. The thing is, most of people who are going to be using an Electron application already have Chrome browser in their infrastructure, and they are really happy with the way it operates because it's a great job. So if an app is created that it's a great job, even though it's heavy in resources, it will not be as heavy as Chrome browser, and it will not register that much with the software with the user's resources. So besides that, Electron offers an amazing user experience. It's easy to just pick up and start working on, and this is why lots of developers are still working with Electron and to build some awesome stuff. And this goes from just individual developers who are developing some new exciting technology to big companies like Microsoft and GitHub themselves and Slack. They are continuing using this technology, and this is an actual conscious choice of the technology itself. So to start building our application, the first thing we did is we had our model, we fed it to this Slack app. So of course we used the modularity of framework we added to add core functionality. We also used a mix of large application structure and some simple Python models. And once we were done with that, we compile it using Electron. So Electron is an npm package, so it can be installed using npm install Electron. Of course, you will have to have Node.js and npm installed, and Electron come at the same time with the package itself and with a binary that is adaptable to HOS. Once you install the Electron to start, it's just as simple as creating a package.json to initiate the node packages and creating index. I'm sorry, and creating a main.js, which is basically going to be where you're going to declare the major functionality of the application. Since we were running since we are running a Flask app, we just pointed to the URL of the app, but otherwise you can just add HTML files to your Electron app, and they are going to be going to be compiled as a desktop application. The next thing we needed to compress our Flask application as a PyZip installer. This is done for a lot of reasons, but the major one is it provides a consistency in the way the app is run under any OS, and it compiles a version of the Python interpreter with with each application, and that helps a lot with consistency. So next thing we did is we added the child processor that's going to be running the Flask application. Actually, Electron has the ability, not just in general, and Electron specific has the ability of running Python as a child process inside the application. So you don't have to start multiple processes, you just have to start one application, and it's going to start everything. And we added a loading page that is important because loading the Flask server will require a little bit of time. And adding this page gives our user the ability to know that the page itself is loaded. As you can see here, we just created a simple HTML page, and using the slash built-in, and using the load file built-in function, we can create a loading page. Next thing we did is we needed to package our application, and for that, Electron has already a great tool called Electron Packager, where you just point some major we add some flags to point to some resources, and that will be used to package up either the icon, if you need to ignore some files, which platform you are packaging to, and the destination file. As you can see here, there is a word author. It's something that we're gonna see next. We need to add some menu to extend the functionality of the application. Electron has a built-in built-from template menu that's often used to add the native menu. And once you are ready to package your application and you are ready to send it to the public, you need to protect your source code. And for that, you can use author. It's basically just a way of putting your code in a way that it cannot be reverse engineered. This compression, though, will make your app enable to add sorry. Will you make your app enable to add any data on it? So for for some, not only for smart information, but for any kind of information that you need to add to the system after the app is installed. You can use the built-in function to detect the OS and store this data in the app in the file system. You have both options. Either you use it in the Python code, or you use it in the Electron version, and it's gonna work perfectly. This is often used to either access some additional file or some key or something or some configuration that is needed. But for the database itself, it is possible once you compile the Flask app to be able to write and read from the database. So often you will compile a version of the database with your application. The talk itself was a little bit heavy in electoral model Flask because for a Python crowd, I think you are more interested in Electron than in Flask. So if you go to electron.js.org, they have a great documentation. They explain everything. They even have a getting started repo that you can just clone, and you can start your application from directly. Any questions?